Stereolithography is a rapid prototyping process used to create parts from 3D CAD data in a matter of hours. SLA is a highly accurate additive manufacturing process and may also be referred to as rapid prototyping or 3D printing. Models created with this technology are typically used as concept models for form and fit studies or as master patterns for molding techniques. The SLA process begins when CAD data is sliced into thin cross-sections or layers, typically about 0.006 of an inch thick. This data is then transferred to an SLA additive manufacturing system containing a vat of UV curable photopolymer. The machine begins to build the part one layer at a time. Each layer is constructed from an ultraviolet laser that is directed by X and Y scanning mirrors. As the laser traces the cross-section on the surface of the resin, the liquid material is hardened on contact. Once a layer is complete, the build platform is indexed down to make room for the next layer. A recoater blade moves across the surface, ensuring a thin coat of fresh liquid resin is evenly spread over the object. The laser continues to trace and form each layer atop the previous layer, building from the bottom up. The completed part is then carefully removed from the liquid and separated from the platform. A chemical bath removes excess resin, and the part is cured in an ultraviolet oven. Any support structures are removed at this time. With numerous hand sanding and professional paint options available through service providers such as Solid Concepts, stereolithography has become an excellent economic choice for rapid appearance models. A wide variety of industries have embraced SLA, including medical, automotive, entertainment, aerospace, and consumer products. Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual-heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers such as Solid Concepts offer multiple finishing options to create smooth, even surface parts including hand sanding, assembly, and cosmetic paint. Since FDM parts are constructed with production-grade thermoplastics, including ABS, polycarbonate, and Ultem, they are both functional and durable. FDM is utilized in a number of industries, including aerospace, automotive, industrial, commercial, and medical. PolyJet is a layer additive manufacturing technology used to develop plastic prototypes from 3D CAD data. This rapid prototyping process uses inkjet technology combined with UV curable materials to quickly and economically produce highly detailed and accurate physical prototypes. PolyJet is one of the fastest prototyping processes available to develop high-precision physical parts and is ideal for smaller parts, appearance models, and master patterns. The PolyJet process begins by slicing CAD data into cross-sections or layers as thin as 6/10,000ths of an inch. The data is then transferred to the PolyJet machine, which begins constructing the object one layer at a time. Similar to how an inkjet printer lays down pigment, the PolyJet printhead deposits small amounts of ultraviolet curable material on the build platform, eventually forming a single cross-section of the part. An ultraviolet light attached to the printhead simultaneously cures the material as it is printed. Once a cross-section is complete, the build platform is lowered slightly to make room for the next layer. As the part is built, support material is added to give supplemental strength to fine structures and down-facing surfaces. After all of the layers have been created, the finished part is removed from the platform and cleaned. Although finishing is not necessary, a number of hand sanding and paint options are available through service providers such as Solid Concepts. PolyJet parts are well suited for quick, economical prototypes requiring exceptional detail, surface finish, and edge visualization. PolyJet is ideal for a wide range of industries, including medical, entertainment, consumer products, automotive, and industrial design.
My name's Gary Fudge. I'm the Director of Sales for the Americas for MCore Technologies. Today we're showing our Iris, our full color Iris printer. It has 1 million plus colors. It prints using standard office copy paper as the main material for the system. What that translates into for our customers is a very high quality color and parts at a very low cost. The way we do color, very simply, is we take a 2D color printer and we apply color on both sides of a sheet of paper. So we use just standard office copy paper. We print on both sides of the paper, and we use a special ink that goes all the way through the paper. We use CMYK, so you can get 1 million plus colors. And the reason why we use a special ink that goes through the paper is because you need full color density on the model. So if you didn't have ink through the paper, the sides of the parts would be white. So we need to get full color on the tops, bottoms, and sides of the parts. Once we color our paper, we feed it through our system here. It comes through the system, it feeds in one sheet at a time. So we take a sheet of paper, we cut the cross section for that particular layer using a tungsten carbide tip. Then we apply adhesive to that layer. And then we add the next sheet of paper, and then we just repeat the process over and over again until you get a stack of sheets of paper. And we pull that out, and then you remove the excess material, and you have your part or parts inside. Most parts are a few hours to overnight build, so it's very comparable to most other 3D printing technologies. Learn more about it, you can go to our website at www.mcoretechnologies.com.
Subiste en Instagram o en Facebook. En Instagram está, ¿lo tenés? Es Instagram.com.
Ay, siempre te firmé las Malvinas. Video de las flores lo subí en internet o...
Subiste.
physical product.
Almost anything you can imagine, people are creating. I think it's going to open up whole new opportunities in areas of mass customization.
Unlike with music or movies, with a 3D printer, a lot of things that are printed aren't protected by copyright.
One of the really cool things about 3D printing is it really changes the dynamic of a consumer culture. It turns you from being a passive consumer to an active creator.
3D printing is this amazing new technology where you can take a 3D digital file and with the click of a button, use that file to create an actual physical 3D part. So how does a 3D printer work? The first step is to get a 3D file, and you can get your 3D file in one of two ways. One, you can simply download the file from the internet. The second way is you can design your own 3D part. The software is going to slice your part up into layers. By building a part layer by layer, you're able to create a plastic part in 3 dimensions, and the possibilities are limited only by your imagination. People will create their next big invention, or engineers and designers create small production runs or little prototypes. Teachers can use it to print out teaching aids. If a teacher is doing a little lesson on a ship, they can actually print out a sailing ship and pass it around the class. And people print out things for around the house. iPhone cases are pretty big. You break a towel hook, you can print out a new one. We want to make 3D printers at a price that the average person can afford and also easy to use. We're already seeing late stage early adoption of 3D printing, but for me the exciting thing is what's to come.
Shapeways is an online 3D printing community and marketplace. Anyone in the world can upload their 3D model and we'll print it for you. And then also, if you decide you want to make it for sale, you can sell it and we'll produce it on demand for that customer wherever they are in the world. You can essentially bring a product to market with no risk. You don't have inventory anymore. You don't have to make sure that there's a market ready for your product. If you sell one, that's awesome. If you sell 10,000, then all of a sudden you have a passive income model, and that radically changes the economy. Usually to bring a product to market takes a year, and then you have to find the manufacturer and the investor, and so it's going to force us to change the way we think about not only buying products but how they're made. One of our colleagues broke his stroller, and it would have cost him something like $250 to get that part in the mail from the stroller company, and he literally just 3D printed a stroller part and got it for $20. You have this explosive technology where everything is made just for you, but at the price and quality of something you buy in a store. This could be a scary technology for some companies, because what does that mean for seasons now? You have infinite inventory, and what does it mean for scarcity, which is one of the core tenets of so many industries? I think it's very similar though to social media or other tools of engagement where you're afraid to see what that would mean to let consumers co-create with you, or to really rethink your traditional manufacturing process because you have so many middlemen. I think we just have to stop thinking that you need to reach 100,000, 1 million people for something to be successful. Customization is really changing the way that we have to think about design and production as well.
People who make money by selling things that are all of a sudden easily copied with a 3D printer are going to be worried that people are going to be making unauthorized copies with those 3D printers. And I think one of the challenges for them is going to be, well, how do I react? Objects that are artistic objects, that are objects that you would hire an artist to make, those things are all going to be protected by copyright. But those objects that actually do things, that have a use besides just sort of entertaining or looking nice, a lot of those are going to fall outside of the scope of copyright. They might be protected by patent, but a lot of them won't be protected by any sort of intellectual property at all. And as a result of that, you can use them or improve upon them or build on them as much as you want, and no one can stop you. 3D printing right now is at its very beginnings. And so you don't have a lot of case law about everyday people making exact copies of physical objects, and certainly not a lot of case law about people being able to do that on a large scale. The good thing, hopefully, is that the industries that are disrupted by 3D printing have the model of the music industry to maybe learn from. The music industry, when someone started copying things, decided the best thing to do was take their time and their money and invest it in suing everyone they could find and try and stop the progress of technology. That didn't work very well. And so the hope is that these creators, when they see this new technology, they capture some of the upside and they say, oh, wait, this can change my business for the better. And they do that. It's a hard thing to do, but the music industry has taught us that it may be the thing they have to do.
3D printing is going to have a profound impact on all of us, whether you consider yourself a designer or not. In the future, there are going to be 3D printers that will allow you to actually create three-dimensional structures out of living cells. And they can build very complex structures like blood vessels or skin tissue. And the idea there is that in 10 or 20 years, these scientists are going to be able to 3D print tissue that could replace damaged vessels of the heart, or they're going to be able to print replacement organs. So you won't have to go to find an organ donor anymore. You'll just be able to have one 3D printed at the hospital based on your own cell and your own genetic makeup. Right now at MIT, scientists are working on 3D printers that would actually allow you to print food. And who wouldn't want that in their house, right? If you could just ask Siri to cook you a steak. I mean, it's really going to be an exciting time in the home. In Japan, there's a company that's taking sonogram data. So they scan a pregnant woman's belly, and they're able to actually 3D print a figure of her torso. So instead of just having a fuzzy little black and white picture, you're getting a real model of what your child is going to look like. People are using 3D printers to do all sorts of interesting things in terms of the environment. Researchers are using 3D printers that can print concrete to make replacements for parts of the Great Barrier Reef that have been damaged. Normally, those reefs take thousands of years to build, but what these scientists do is they find the areas that are damaged, they make CAD replicas of those damaged areas, and they print them in concrete. So it's a base structure upon which coral can create a top layer, and that helps reinvigorate the environment and helps return normality to that area. I mean, one of the coolest things about 3D printing is that it's a community that never stops innovating. There are hundreds of innovators who are making little tweaks to these products, who are trying out different things, and so it really gives everybody an opportunity to create anything they could imagine.
3D printing is the next wave of how brands and consumers can engage, and now we're just starting to see that happen.
In a few years' time, they're going to be no more difficult to use or difficult to understand than a camera phone.
The way to protect creators and designers is to make sure to give people a way to spend money on 3D printed things.
In the future, we're going to see a lot more people